This video is about the Mann-Whitney U-test. In short, it is also called as MWU test. The Mann-Whitney U-test is a non-parametric alternative of the independent samples t-test. Then you may be curious when to use this non-parametric alternative. First, when your sample is too small. Too small is a very subjective expression. In Mann-Whitney U-test, when any of the two samples is smaller than 10, it is recommended to select Mann-Whitney U-test rather than to perform the independent samples t-test. Second, when your data are not fitting to the normal distribution. For instance, you have collected the data and the distribution looks like the back of a camel or M-shaped rather than normal distribution. Then, in this case, you cannot say the mean, which might be somewhere here, can represent the central tendency of your sample. And this means it's not appropriate to assume how the population data would look like. Then you can conduct the Mann-Whitney U-test. Third, when your variables are measured in a hierarchical scale or ordinal scale. Some scientists insist that the interval scale is not really numerical representation or numerical quantity, and therefore they insist that non-parametric tests are more proper than parametric tests to analyze the interval scale. If you are unlucky enough, you will meet those reviewers who would say in such a way. However, please be relaxed. The majority of social scientists, including design researchers, consider the interval scale to be appropriate for the parametric statistics. Therefore, only when you have measured the data in a hierarchical scale, such as rankings, it is recommended to perform the Mann-Whitney U-test. Let's consider this example. Did you have breakfast this morning? 정경아 took this image at 학식 this morning. I barely see any female students here. I'm very afraid that you will ruin your health due to too much of overnight work. Anyway, let's consider this case. You ask 16 people about two things, so two variables. One is a very embarrassing question, and the other one is, okay. And so, first question about the rank. So this variable is measured in, hierarchical scale. The other one is about whether they had breakfast or not. Therefore, this variable is measured in nominal scale. 1 means yes and 2 means no. Because breakfast group is different from non-breakfast group, you have actually two independent groups. So anyone can belong to either this group or this group. And suppose your hypothesis is whether the breakfast would influence or help students perform better in exam. Based on my observation, the first ranked student had breakfast, whereas the last ranked student didn't. The Mann-Whitney U-test is suitable for this case in order to examine whether the ranks of each independent group is statistically different, or whether the ranks of each group has the statistical different tendency. So when to use this Mann-Whitney test? The Mann-Whitney test is used to compare the central tendency of two independent samples by quantifying the ranked positions of each sample. Then let me show you how to go on. I rearranged this data, and the first row indicates the rank, and the second row indicates whether each student had breakfast or not. In Mann-Whitney test, you need to calculate two U values. The two U values are labeled as U1 and U2. The R here is the sum of ranks of each group. In this case, I count the ranked places of yes group people. So the sum of the rank of yes answered is 1 plus 3 plus 4 plus etc. and then 15. So this is actually the R1. And N1 indicates the size of this group, so 8. In this way, we can calculate U1, and this is 27. Then you need to calculate the R2 and then U2. You will see that the U2 will result at 37. When you have U1 and U2, take the smaller U value. So in this case, U1. And we consider this U1 as the U value of this data. So the U value of this data is 27. And please remember this number for the next process. The Mann-Whitney test refers to the standard normal distribution, and the set value is calculated by dividing the difference between the U and the mean U through the standard deviation U. The mean U and the standard deviation U can be obtained through this formula. Remember, the U was 27, and MU will be 64 divided through 2, so MU will be 32. And then sigma U is approximately 9.52. So you use these three numbers, and then you will obtain the set value like minus 0.52 something. In the normal distribution, the Z value should be either bigger than 1.96 or smaller than minus 1.96. In order to conclude the p-value is, so the size of this shaded area is smaller than 0.05. Therefore, the Z value is still within this area. Minus 0.52 should be somewhere here, right? So consequently, the result does not support my hypothesis that breakfast helps students perform better in exams. The difference of the ranks of two groups does not show the statistical significance. But still, please eat some hydrocarbonate to empower your brain in the morning. Okay, then let me show you how we perform the Mann-Whitney test in SPSS. Okay, in SPSS, I copied the data, and the number 1 indicates yes, they had a breakfast, and the 0 indicates no, I didn't have the breakfast, and here I copied the rank data. Okay, and then analysis, non-parametric statistic, and here independent 2 samples. And for comparison, for the test, I put the rank data here, and for the comparison, I defined 1 and I should define here 0, and the type of test is mann whitney U test. Okay, here do you remember that our U value was 27? Okay, and it already presents us the Z value, which is minus 0.5253, and the p value is far bigger than 0.05 here, as we have seen in the slide. So again, here shows us, the result shows us that actually the breakfast, it doesn't influence, or the influence of the breakfast on students' performance in exam is not statistically significant.